The Norwegian heavy water sabotage was a series of actions undertaken by Norwegian saboteurs during World War II to prevent the German nuclear energy project from acquiring heavy water, which could be used to produce nuclear weapons. In 1934, at Vemork, Norsk Hydro built the first commercial plant capable of producing heavy water as a byproduct of fertilizer production. It had a capacity of 12 tons per year. During World War II, the Allies decided to remove the heavy water supply and destroy the heavy water plant in order to inhibit the Nazi development of nuclear weapons. Raids were aimed at the 60 MW Vemork power station at the Rjukan waterfall in Telemark, Norway. Prior to the German invasion of Norway on April 9, 1940, the Deuxième Bureau removed 185 kilograms of heavy water from the plant in Vemork in then neutral Norway. The plant's managing director, Aubert, agreed to lend the heavy water to France for the duration of the war. The French transported it secretly to Oslo, to Perth, Scotland, and then to France. The plant remained capable of producing heavy water. The Allies remained concerned that the occupation forces would use the facility to produce more heavy water for their weapons program. Between 1940 and 1944, a sequence of sabotage actions, by the Norwegian resistance movement as well as Allied bombing ensured the destruction of the plant and the loss of the heavy water produced. These operations codenamed Grouse, Freshman, and Gunnerside finally managed to knock the plant out of production in early 1943. In Operation Grouse, the British Special Operations Executive successfully placed 4 Norwegian nationals as an advance team in the region of the High Danger Plateau above the plant in October 1942. The unsuccessful Operation Freshman was mounted the following month by British paratroopers. They were to rendezvous with the Norwegians of Operation Grouse and proceed to Vemork. This attempt failed when the military gliders crashed short of their destination, as did one of the tugs, a Handley Page Halifax bomber. The other Halifax returned to base, but all the other participants were killed in the crashes or captured, interrogated, and executed by the Gestapo. In February 1943, a team of SOE-trained Norwegian commandos succeeded in destroying the production facility with a second attempt, Operation Gunnerside. Operation Gunnerside was later evaluated by SOE as the most successful act of sabotage in all of World War II. These actions were followed by Allied bombing raids. The Germans elected to cease operation and remove the remaining heavy water to Germany. Norwegian resistance forces sank the ferry, SF Hydro, on Lake Tinsja, preventing the heavy water from being removed. Technical background: Enrico Fermi and his colleagues studied the results of bombarding uranium with neutrons in 1934. The first person who mentioned the idea of nuclear fission in 1934 was Ida Noddack. 4 years after the Fermi publication, in December 1938, Lise Meitner and Otto Frisch correctly interpreted the radiochemical experimental results of Otto Hahn and Fritz Strassmann as evidence of nuclear fission. News of this discovery spread quickly among physicists, and it was realized that if chain reactions could be tamed, fission could lead to a promising new source of power. What was needed was a substance that could moderate the energy of neutrons emitted in radioactive decay, so that they could be captured by other fissile nuclei. Heavy water and graphite were the prime candidates for moderating the energy of neutrons. When Nazi Germany investigated the production of an atomic bomb, a range of options was identified. Although historical records provide limited detail on the German decision to pursue the heavy water approach, it became clear after the war that they had explored the option. Although ultimately unsuccessful, the approach chosen has been demonstrated to be technically viable. Plutonium-239 makes an effective weapons material. Heavy water has been demonstrated as an effective moderator for 239Pu production. Heavy water may be separated from ordinary water by electrolyses. Approaches to developing a weapon. In nuclear weapon development, the main problem is securing sufficient weapons-grade material. In particular, it is difficult to acquire either fissile isotopes of uranium-235 or of 239Pu. Weapons-grade uranium requires mining, extracting and enriching natural ore. Alternatively, Plutonium can be bred in reactors fueled by unenriched uranium, which requires chemical separation of the 239 Pu produced. Unlike the Allies, who pursued both the enrichment of uranium and the production of plutonium, German scientists only focused on plutonium production, as this method was less expensive. Plutonium production equals, although the most common isotope of uranium, uranium-238, can be used as secondary fissionable material in hydrogen bombs, it cannot be used as the primary fissile material for an atomic bomb. 238U can be used to produce 239 Pu, through the fission of 235U, which produces neutrons, some of which will be absorbed by 238U, creating 239U. After a few days the 239U will decay, turning into weapons-usable 239 Pu. The Germans did not examine ultra-pure graphite because they did not know that the graphite they had tried was too impure to sustain a chain reaction, and abandoned it as a possible moderator. They instead settled on the heavy water-based reactor design. A heavy water moderated nuclear reactor could be used to do nuclear fission research, and, ultimately, to breed plutonium from which a bomb could be constructed. Heavy water production equals. Heavy water occurs in very low concentrations in normal water but is more concentrated in the residue of water used as an electrolyte. An analysis of the residues from the Norwegian Vemork hydroelectric plant, run by Norsk Hydro, near Rjukan in the Telemark region, a large-scale hydrogen production plant using electrolysis of water for ammonia production, showed a concentration of 1 part in 2,300. Leif Tronstad, then lecturer at the Norwegian Institute of Technology, and Joma Brun, head of a hydrogen plant, put forward a proposal in 1933, the year heavy water was first isolated, for a project, which was accepted by Norsk Hydro and production started in 1935. The technology is straightforward. Heavy water is separated from normal water by electrolysis because the difference in mass between the two hydrogen isotopes translates into a slight difference in the speed at which the reaction proceeds. To produce pure heavy water by electrolysis requires a large cascade of electrolysis chambers, and consumes large amounts of power. Since there was excess power available, heavy water could be purified from the existing electrolyte. As a result, Norsk Hydro became the heavy water supplier for the world's scientific community, as a byproduct of fertilizer production, for which the ammonia was used. Hans Suess was a German advisor to the production of heavy water. Suess had assessed the Rjukan plant as being incapable of producing militarily useful quantities of heavy water in less than 5 years at its then capacity. Operations to limit German access to heavy water. Pre-invasion efforts equals, French research considered production of 239 Pu using both heavy water and graphite-moderated reactors. Preliminary French research indicated that the graphite which was then available commercially was not pure enough to serve the purpose, and that heavy water would be required. The German research community had reached a similar conclusion and in January 1940 had procured additional heavy water from Vemork. The German firm IG Farben, which was a partial owner of Norsk Hydro, had ordered 100 kilograms month. Norsk Hydro's maximum production rate was then limited to 10 kilograms month. In 1940, the Deuxième Bureau directed 3 French agents, Captain Muller and Lieutenants Mosse Copyright and Nordimars, to remove the world's extant supply, 185 kilograms of heavy water from the plant in Vemork in then neutral Norway. The Norsk Hydro General Director, Axel Aubert, agreed to lend the heavy water to France for the duration of the war, observing that if Germany won the war, he was likely to be shot. Transportation was difficult as German military intelligence maintained a presence in Norway and had been alerted of ongoing French activities in Norway. Had they become aware of the shipment, they might have attempted to intercept it. The French transported it secretly to Oslo, to Perth, Scotland and then to France. When France was invaded, the French nuclear scientist Rick Joliot-Curie took charge of the material, hiding it first in a Banque de France vault and then in a prison. Joliot-Curie then moved it to Bordeaux, where it, plus research papers and most of the scientists boarded the British tramp steamer Broompark, which was one of the many merchant ships involved in saving over 200,000 troops and civilians in the 3 weeks after Dunkirk. The ship already had industrial diamonds, machinery and a number of British evacuees aboard. SS Broompark delivered its passengers and cargo, together with all of the free supply of heavy water, to Falmouth on June 21. The award of an OBE to Captain Polson was recorded in the London Gazette of February 4, 1941. Crucial to the success of the mission was the role played by Charles Howard, 20th Earl of Suffolk. Although the ready inventory of heavy water was removed, the plant remained capable of producing heavy water. In investigations of collaboration launched by Norwegian authorities after the war, Norsk Hydro management's collaboration with the Germans was considered. General Director Aubert's cooperation with the French aided the Norsk Hydro case. Operations Grouse and Freshman equals. Destruction of the plant was mounted by the Combined Operations Command in November 1942. The plan consisted of 2 operations. The first would drop a number of Norwegian locals into the area as an advance force, and once they were in place a party of British engineers would be landed by military glider to attack the plant itself. On October 19, 1942, a 4-man team of Special Operations Executive-trained Norwegian commandos parachuted into Norway. From their drop point in the wilderness they had to ski a long distance to the plant, so considerable time was given to complete this part of the mission, known as Operation Grouse. This plan, unlike prior failures, included the team studying and memorizing blueprints. Once the Norwegian Grouse team managed to make contact with the British were suspicious, as they had not heard from the SOE team for a long time. They had been dropped at the wrong place and had gone off course from there several times. The secret question took the form of, "What did you see in the early morning of?" The Grouse team replied, "3 pink elephants." The British were ecstatic at the success of the Norwegian team's insertion, and the next phase of operations commenced. On November 19, 1942, Operation Freshman followed with the planned glider-borne landing on frozen Lake Maui SVATN near the plant. 2 S-Speed Horsa gliders, towed by Handley Page Halifax bombers, each glider carrying 2 pilots and 15 Royal Engineers of the 9th Field Company, 1st British Airborne Division, took off from RAF Skitton near Wicken Caithness. The towing of gliders had always been hazardous, but in this case it was made worse by the long flying distance to Norway and poor weather conditions which severely restricted visibility. One of the Halifax tugs crashed into a mountain, killing all 7 aboard. Its glider was able to cast off, but crashed nearby, resulting in several casualties. The other Halifax arrived at the area of the landing zone, but although the conditions had substantially improved it was impossible to locate the landing zone itself, owing to the failure of the link between the Eureka and Rebecca beacons. After much endeavor and with fuel running low, the Halifax pilot decided to abort the operation and return to base. Shortly afterwards, however, the tug and glider combination encountered heavy cloud and in the resulting turbulence the tow rope broke. The glider made a crash landing, not far from where the other glider had come down, similarly inflicting several deaths and injuries. The Norwegians were unable to reach the crash sites in time, and the survivors eventually came into the hands of the Gestapo, who tortured them during interrogation and later had them executed under Adolf Hitler's commando order. The most important consequence of the unsuccessful raid was that the Germans were now alerted to a determined Allied interest in their heavy water production. The Norwegian Grouse team thereafter had a long arduous wait in their mountain hideaway, subsisting on moss and lichen during the winter until, just before Christmas, a reindeer was encountered. Operation Gunnerside. British authorities were aware the Grouse team was still operational, and decided to mount another operation in concert with them. By this time the original Grouse team was being referred to as Swallow. On the night of February 16, 1943, in Operation Gunnerside, an additional 6 Norwegian commandos were dropped by parachute by a Halifax bomber of 138th Squadron from RAF Chelmsford. They were successful in landing, and encountered the Swallow team after a few days of searching on cross-country skis. The combined team made final preparations for their assault, which was to take place on the night of 27/February 28, 1943. Supplies required by the commandos were dropped with them in special CLE containers. Army Air Corps, who were exercising in the area. The container was brought back to England and was displayed in the Airborne Museum at Aldershot. The museum closed in 2008 and is now part of the Imperial War Museum Dewford. Following the failed freshman attempt, the Germans put mines, floodlights, and additional guards around the plant. While the mines and lights remained in place, security of the actual plant had slackened somewhat over the winter months. However, the single 75 m bridge spanning the deep ravine, 200 m above the river Mayeni, was fully guarded. The force elected to descend into the ravine, ford the icy river and climb the steep hill on the far side. The winter river level was very low, and on the far side, where the ground leveled, they followed a single railway track straight into the plant area without encountering any guards. Even before Grouse landed in Norway, SOE had a Norwegian agent within the plant who supplied detailed plans and schedule information. The demolition party used this information to enter the main basement by a cable tunnel and through a window. Inside the plant, the only person they came across was the Norwegian caretaker, who was very willing to cooperate with them. The saboteurs then placed explosive charges on the heavy water electrolysis chambers, and attached a fuse allowing sufficient time for their escape. A Thompson submachine gun was purposely left behind to indicate that this was the work of British forces and not of the local resistance, in order to try to avoid reprisals. A bizarre episode ensued when fuses were about to be lit. The caretaker was worried about his spectacles, which were lying somewhere in the room. A frantic search for the caretaker's spectacles ensued. They were found and the fuses lit. The explosive charges detonated, destroying the electrolysis chambers. The raid was considered successful. The entire inventory of heavy water produced during the German occupation, over 500 kilograms, was destroyed along with equipment critical to operation of the electrolysis chambers. Although 3,000 German soldiers were dispatched to search the area for the commandos, all of them escaped. 5 of them skied 400 kilometers to Sweden, 2 proceeded to Oslo where they assisted Milorg, and 4 remained in the region for further work with the resistance. Resumed operation and Allied air raids. Although this attack did no irreparable damage to the plant, it did stop production for several months. The Vemork plant was restored by April and SOE concluded that a repeat commando raid would be extremely difficult, as German security had been considerably improved. Almost as soon as production restarted, the USAAF started a series of raids on Vemork. In November, the plant was attacked by a massed daylight bombing raid of 143 B-17 heavy bombers dropping 711 bombs, of which at least 600 missed the plant. The damage, however, was quite extensive. On November 16 and 18, 35 B-24 heavy bombers from the 392nd Bomber Group out of Wendling, Station 118, attacked the hydroelectric power station at Rjukan with excellent coverage of the target. The missions were the longest for this bomber group, lasting 9½ and 10½ hours respectively. The need for ground assaults was reduced from a year earlier as there was now an available alternative of night bombing, which had previously been unrealistic owing to German air cover. The Germans were convinced that air raids would result in further serious hits, and they decided to abandon the plant and move remaining stocks and critical components to Germany in 1944. Sinking the SF Hydro on Lake Tinzja. Knut Haukelid, who was the only trained commando in the immediate area, was informed of the German plan to remove the heavy water and advised he would have to muster support and destroy the shipment. He decided to sabotage the ferry carrying the heavy water across Lake Tinzja. He recognized a ferry crew member and talked to him, taking this advantage to slip into the bottom of the ship and plant the bomb, after which he slipped away. 8½ kilograms of plastic explosive with 2 alarm clock fuses were fixed to the keel of the ferry, SF Hydro, which was to carry the railway cars with the heavy water drums across Lake Tinzja. On February 20, 1944, shortly after setting off around midnight, the ferry and its cargo sank in deep water, finally capping the original mission's objective and halting Germany's atomic bomb development program. A number of Norwegian civilians were killed as the ferry sank. Witnesses reported seeing steel drums floating after the sinking, leading to speculation that they did not really contain heavy water, but an examination of records after the war showed that some barrels were only half full, and therefore would have floated. A few of these may have been salvaged and transported to Germany. In 2005, an expedition retrieved a barrel from the bottom of the lake. Its contents of heavy water matched the concentration noted in the German records, and confirmed that the shipment was not a decoy. However, it also supported the notion that the concentration of heavy water in a number of the barrels was too small to be of value to a weapons program. This might explain the absence of heavy security measures around the shipment, including why the ferry itself was not searched for delayed charges. In the film, Heroes of Telemark, the locomotive and train is shown, somewhat implausibly covered with German soldiers. In the Ray Mears BBC coverage, it is stated that in fact the general in command had ordered this specific disposition of troops. Unknown to the saboteurs, a Plan B had been established by the SOE, who arranged a second team to attack the shipment at Hera Yar should the first attempt fail. The disassembled factory was later found in southern Germany during the closing stages of the war by members of the Operation Alsos nuclear seizure force. Historical perspective. Recent investigation of production records at Norsk Hydro and analysis of an intact barrel that was salvaged in 2004 revealed that although the barrels in this shipment contained water of penthouse 14 indicative of the alkaline electrolytic refinement process, they did not contain high concentrations of D2O. Despite the apparent size of shipment, the total quantity of pure heavy water was limited, with most barrels only containing between 0.5% pure heavy water, confirming the success of the Operation Gunnerside raid in destroying the higher purity heavy water. The Germans would have needed a total of about 5 t of heavy water to get a nuclear reactor running. While the manifest indicated that there was only 500 kilograms of heavy water being transported to Germany. Hence the Hydro was carrying too little heavy water to supply one reactor, let alone the 10 or more tons of heavy water needed to make enough plutonium for a nuclear weapon. With the benefit of hindsight, the consensus on the German wartime nuclear program is that it was a long way from producing a bomb, even if the Norwegian heavy water bin produced and shipped at the maximum rate. Nevertheless, the unsuccessful British raid and defeats of the Norwegian saboteurs made the top-secret war against the heavy water production internationally known and the saboteurs national heroes. SOE Norwegian agents involved, the first agent inside the plant, Einar Skinnaland, the Grouse Swallow team, Jens Anton Poulsen, Arnk Jestrup, Knut Haugland, Klaus Hellberg, the Gunnerside team, Joachim Hombo Ryenberg, Knut Hauklid, Fredrik Kaiser, Kasper Idland, Hans Storhaug Bergestraven UMSHEIM, Leif Trunstad, the Lake Tinsja team, Knut Hauklid, alias Bonzo, Nudlia Hansen, Rolf Zarrlie, Einar Skinnaland, Gunnar Siverstad, Kjell Nielsen, Larsen, N.N. Published Histories, a 1962 book by John D. Drummond, titled But for These Men, tells a true account of two dramatic raids, one on the Norsk Hydro heavy water factory at Vemork, and another on the railway ferry Hydro to destroy Germany's heavy water production efforts. The book The Real Heroes of Telemark, The True Story of the Secret Mission to Stop Hitler's Atomic Bomb by Ray Mears, published by Hodder and Stoughton 2003, describes the event from the perspective of the unique survival skills of the Norwegian commandos. It accompanied a BBC television documentary series, The Real Heroes of Telemark, which sticks more to the facts than the film it is named after. It also describes the survival aspects of the attack, how to survive for months in a mountain cabin. The book skis against the atom is a first-hand account by Knut Hauklid, one of the Gunnerside raiders who stayed behind. Jens Anton Poulsen has told the story in the book The Heavy Water Raid, The Race for the Atom Bomb 1942–1944, Orion 4 Lagers, ISBN 978-82-458-0869-8. The ill-fated Operation Freshman is covered extensively in two books, Richard Wigan's Operation Freshman, The RJUKAN Heavy Water Raid 1942, William Kimber and Company Limited, ISBN 978-0-7183-0571-0, and the more recent, Joe Steinberg-Lide's Operation Freshman, The Actions and the Aftermath, Lendua and Ekholm, ISBN 978-975,895-9-8. Richard Rhodes's Pulitzer Prize-winning book The Making of the Atomic Bomb includes details on the events in chapters 14 to 15. Leo Mark's 1998 book Between Silk and Cyanide, A Codemaker's Story 1941 to 1945 covers the story in some detail. Marks was SOE's cryptographer. He knew the Norwegian team, trained them in cryptography so they could communicate with SOE back in England, and avidly followed their progress after they were dropped in Norway. Published by HarperCollins. ISBN 0-684-86780-X. The raid is also the subject of the book, Assault in Norway, Sabotaging the Nazi Nuclear Program by Thomas Gallagher, published by Leon Press, ISBN 978-1-58574-750-4. This book is based on the author's interviews with many of the commandos. Fiction, film and video coverage. A 1948 Norwegian movie based on Operations Freshman and Grouse, called Kampen om Tungtvannet, features performances by at least 4 of the original participants in the raid. A 1965 British movie based on the Operation Gunnerside raid, titled The Heroes of Telemark. It features a performance by one of the original participants in the raid as the Nazi pursuer of the escapees. A 1979 Canadian movie and TV series titled A Man Called Intrepid, based on the book of the same name by William Henry Stevenson. It features David Niven, Michael York and Barbara Hershey. A 1966 book by Czechwolf Francha Ek Bahonek, titled Rokoli Rjukanu, is a fiction inspired by the events. On November 8, 2005, the Corporation for Public Broadcasting WGBH Educational Foundation in Boston, Massachusetts aired a program which documented the work of a team of underwater archaeologists exploring the sunken Ferry, SF Hydro in Lake Tinzja. The game's Blazing Angels squadrons of WWII, Battlefield 1942, Secret Weapons of WWII, Medal of Honor and Enemy Front each include missions involving the destruction of the heavy water plant. On their 2010 album Coat of Arms, Swedish power metal band Sabotage has a song named Saboteurs, detailing the operation. A 6-episode TV mini-series titled The Heavy Water War tells the story with a particular emphasis on the role of Leif Trunstad. This Norwegian-Danish-British co-production is in 6 episodes, the first of which was initially broadcast on January 4, 2015. In October 2013, it was reported that Danny Boyle and Simon Beaufoy will be creating a 10-part mini-series for FX, currently titled Telemark, to tell the story of the Norwegian saboteurs. While still in pre-production, it is estimated for a 2015 release. References. External links: Nova, Hitler's Sunken Secret, a slideshow from a CNN report about the raids, Vemork raid, Operation Freshman, Norsk Hydro's official site on RJUKAN during the war, interview with Joachim Reinberg, the Assault Glider Trust, Operation Freshman Memorial at RAF Skitten, Operation Freshman Roll of Honor, Awards and Images. Annotated bibliography for Norwegian heavy water sabotage from the ALSO's Digital Library for Nuclear Issues, Bergestromshim, Hero on Skis in an Anti-Nazi Raid, Dies at 101, William Yardley, The New York Times, December 9, 2012.